So this is a question where you can see originally there are two resistors in series, R1 and R2. And if we switch on the switch or if we close the switch, then it becomes a combination of a parallel branch of R2 and R3 connected side by side in series with R1. And if we do this, you are asked what would therefore be the changes to your current and your voltage readings. So the answer is A, and I always like to withdraw the circuit to one without the meters. And I'll replace the meters with the current label or the voltage label. So as I just said, if we switch on and close the circuit, if we switch on and close the switch, then the series circuit becomes a parallel branch of R2 and R3 connected in series to R1. So let's go through this step by step. The moment we close the switch, R2 and R3 combines to become a parallel circuit, and we know that when we add components in parallel, we are actually lowering the effective resistance of the circuit. So when we close the switch, the effective resistance of this parallel branch becomes smaller, and the whole circuit's resistance will therefore also become smaller. When the resistance of the whole circuit becomes smaller, current is inversely proportional to resistance, and therefore the total current in the circuit A1 must increase, and that's our first part of the answer already. Now, with A1 now being a higher value when there's a greater current, if we look at R1, resistor 1, we notice that the higher current will make the voltage across resistor 1 greater. So the voltage value across R1 will also increase. Lastly, if the voltage across R1 increases, then the remaining voltage must go to the parallel branch, and this remaining voltage is a smaller value because R1 took up a bigger voltage value from the EMF. So the parallel branch voltage will therefore now be lower, and when the voltage across R2 is lower, using Ohm's law, it must mean that the current passing through R2 is also lower. And that's how you can get the three answers to this question.